Welcome to Water Resources Engineering class. So we are dealing with Unit 4, that is groundwater hydrology. So in the groundwater hydrology, we have explained what are the basic requirements initially, followed by an unconfined aquifer fully. We have derived the equation, and at the same time we have completed some of the problems in that also. And then later we have taken up the confined aquifer, that also we have completed. Then we have taken up the classification of wells, and in the classification of wells, if you remember, we have taken up in the classification of wells, especially we have taken up this constant pumping test. Open wells we have taken first. In the open wells, constant level pumping test and recuperation tests, both we have completed. Right now in today's class, we are discussing about the tube wells. Even though it is not specifically mentioned in the contents of the syllabus, but I feel that unless you know the complete picture of the whole thing, naturally it is not completed. For example, open wells we have studied, then tube wells is the next part. So wells means both open wells and tube wells we need to know. So that is why in today's class my focus is completely on the tube wells. With this tube wells, the entire groundwater hydrology, whatever is there in your syllabus, that has been completed. So right now let us take it up, this today's focus actually. So naturally we deal with what is a tube well and how to classify the tube wells, and some of the important points like what do you understand by well shrouding, what do you understand by well development, and what is do you know what are the methods of construction of tube wells, and we close with the last topic, what are the characteristic losses, or the same thing is called as well constants. So this is the organization of today's lecture actually. So what is a tube well? A tube well basically is a very deep well actually. Deep well, generally it is of PVC or steel, right? Open well is not that. Open well means where is the difference between the open well and tube well? Open well means the diameter is large. Naturally we go to depth is also less actually. For lower depths only we go for open wells actually. And then whereas the tube wells means there are very shorter diameter, and it is a PVC pipe, and it is drilled deep into the aquifer. They are all deep wells actually. So very deep wells are all tube wells. So these again, both the wells can be constructed in different soils, but what is the type of the well? Based on that characteristic we define it as an open well or a deep well. A deep well is nothing but a very long tube well which is really going very deep into the earth, and especially the material which we can choose is whether it is steel or the PVC pipe. Many of you must have been seen also the rigs which are really boring or which are really constructing the bore wells which to a very larger depths, and that is what we call it as a tube well. Its diameter is generally very less actually. So what is the entire thing in the tube well is it's not just a PVC pipe that goes into the soil actually. This PVC pipe or the steel pipe consists of strainers. Strainer is nothing but a portion wherein it is also a tube wherein the holes are there on the entire periphery actually, so that from the aquifer the water enters into the holes, and thereby the water, when you pump it, the water will come out of that. So that part is mainly thinking you should remember. Because of the strainer that which we have, high velocity you can achieve in the case of the tube well, whereas in the open well such type of facility is not there. And at the same time, what is the purpose of the strainer is also because you can keep straight opening, but the problem is in addition to the water, the soil also will enter into the pipe. So if you want to prevent the entry of soil into the pipe, we need a strainer material, and that is what most important thing in the case of tube well. But in the case of a tube well, the velocity is very high, so the flow is in the radial direction. Because of that radial direction, naturally the area from where the water is being drawn is also very high. Thereby the discharge that through the tube well is much higher compared to the open well. Please remember, even though a tube well diameter is much less actually compared to open well, but the discharge is many times higher when compared to open well. So based on the construction, how you are penetrating into it, how it is being tapping from the aquifer, the tube wells are being classified into, one is strainer well, the other one is cavity well, and the third one is slotted well. These are the three the classification of wells in case of tube wells. Whereas in open wells, we have shallow well, deep well, only two classifications. Here we have in tube wells, three classifications. We call it as strainer well, cavity well, and deep well. So let us take into the strainer well actually. Figures are very important first. When a strainer well is nothing but this one is the way what we call it as the tube actually. So and this tube is penetrating into the soil actually. At the bottom we have kept a plug actually. Then in that case, when you keep a plug at the bottom, from where it is drawing the water, actually when the well is being penetrated into it, or when the well is bored into the soil, then what we ensure is it crosses many aquifers at different layers of the earth. So here there is one aquifer is there, here there is another aquifer. In between these two aquifers, there is an impervious layer like. So we want to draw from these two aquifers the water into the tube well. So that's why this portion of the pipe and this portion of the pipe is such that the holes are being drilled. So that's why we allow the strainer pipes into it such that wherever water is there, at that place this strainer pipe is being kept. And a strainer pipe is nothing but a pipe having holes on the entire periphery. So thereby, because of these holes, the moment you start pumping here, automatically the water is being drawn from the aquifer into the well and it is being pumped outside. That is the basic thing. So kindly remember, in the case of strainer well, number of strainers are being used depending upon the deposits of water in terms of aquifers at different depths in the earth crust. So at all those places we keep these strainers, and the remaining pipe portion is a blind pipe. A blind pipe is nothing but just a pipe, whereas a strainer pipe is nothing but a pipe having holes on the periphery. And at the same time we take precautions such that it allows only water, but it never allows the soil from the aquifer, because aquifer consists of both the soil and water also. So that's why it draws water only, but it doesn't draw basically the soil. So this is one of the things where this type of strainer wells are used. Naturally, fine and medium sands, we use this because it is very easy to construct, and at the same time the discharge is moderate and cost wise is also not much actually, but it is not suitable for very coarse gravel formations. So it is only suitable for fine sand and medium sand it is suitable. So this is one type of the well. The second type of tube well is cavity type tube well, where in the case of cavity type tube well, it is purely a blind pipe that which we are having, but at the bottom actually it is opening. So because of that opening, naturally a cavity like thing portion will be formed at the base, right? Here this is the portion of cavity. Because of that, naturally when you pump it, it draws water from the bottom. Remember, the strainer pipe type well draws radially the water actually from the, whereas it draws from the bottom actually the water. So that should be, you should remember actually. So this is one of the thing. And which type of soils it is more relevant is especially clay, silt and sandy layers. These type of soils, this type of well is more preferred, but the discharge is very low. But it is very simple to construct, just boring into the soil actually, whatever the type of soil, you make a hole into it and then put the pipe actually, and from the bottom you draw the water actually. So the limitation of this is chances of from here sand entry is there and this cavity also may collapse after some time. So that's why it is not suitable at all places. Only a little bit hard soils you can use this type of well. And the third type of tube well is slotted type tube well. In the slotted type tube well, we have a casing outside, and whereas in the middle we have our regular what you call it as the bore well, the third thing. And in that case what will happen is we will be continuously sending the compressed air into it, and thereby naturally if whatever are there, the what you call it as the fine particles here, that will be dislodged, and only thing is the water will be taken through these pipes outside, whereas the central pipe we use it only to send the compressed air so that the soil particles always get not entering into the pipe, they will be moved away, they are always moved away, and that is the thing. But what we do is around the well we will go for shrouding. Shrouding is nothing but packing around the well with some gravel particles wherein the small fine particles will not enter into the pipe and thereby clog the pipe. So that's why padding is done throughout the what you call it as the well, and that is what we call it as well shrouding. Once you do this, you can remove these the casing pipes at the end. So this is what the third type of the slotted type tube well, but it is costlier actually, right? And second one is, but it is very strong and more durable than any type of wells, but discharge is very high and cost is also very high. So what are the methods of construction? Now we have studied what is the classification of tube wells. Tube wells are classified as strainer type, then second one is cavity type, third one is slotted type. Then but that is keep it aside. Now let us go into the construction. What are the methods? At least you need to have an idea about the methods. So what are the various methods actually? There is one method which we call it as a water boring method or water jet boring method, cable tool method, hydraulic rotary method, reverse rotary method. These are the common methods which are used for drilling a bore well into any soil actually. Depending upon the type of the soil, depending upon the quantity that can be extracted, naturally at what depth the water is available, we need to choose that method of the different methods of construction. So if I choose a boring method first, a boring tool is nothing but actually a drill bit. Please just remember, it's a drill bit. Some people call it as it is a auger, drill bit, drill rod, all are same. It is basically a boring tool means a drill bit actually which is rotated continuously in the soil and forced into the ground to remove the soil. So because from the ground we want to remove the soil, then only you can construct the borehole. So how to construct that borehole? So use a boring tool and rotate that boring tool and force it to go into the ground to remove the soil and create a borehole. Once the borehole is ready, a well pipe with the strainers is lowered and shrouding material is filled. Shrouding material is nothing but gravel pack. Suitable for moderately hard soils and aquifers up to 50-meter depth. So this method is very good. If the almost 150 feet, you can go with this method actually, boring method. And in this boring method, there are different types. One is hand boring method. People actually, 2-3 people continuously rotate it and then thereby make it. Then auger boring, normally only sandy soils. Again, it is manual boring. Percussion boring, that is in hard soils by machine drilling. We will take it up that actually. The second method is wash boring method. What is wash boring method? The boring is done by cutting action of a downward directed stream of water. Actually, we will be sending a stream of water downstream. So naturally again a drill bit is there, and that drill bit will be drilling and we will be sending water. So now the soil, naturally this water will go into the soil and naturally it forms a slurry, and that slurry what we will be doing it is we are basically removing it outside. So that if you read it, there will be an outer casing which is first erected in position in a suitable pit dug at the surface. A jet pipe with a nozzle is then lowered into the casing tube and water under pressure is forced into the well. Then the dislodged soil particles and broken pieces from the slurry with water are lifted up through the annular space between the jet pipe and the casing. Now they are removing it. Then what they will do it, the casing pipe have shoes at the bottom actually, and is kept rotated slowly, thus lowered. So it is kept slowly, it is getting lowered. The soil gets removed and the pipe with the strainer gradually go on sinking for unsuitable for loose sandy soils, depths up to 50 meters, up to 150 feet, and cost wise is very, very low. What we are doing here also, again boring only we are doing. While doing boring, naturally whatever the soil particles that dislodges, in order to not to generate heat, we supply water actually, it becomes a slurry, and that slurry is being pumped out and it again goes down like that. Slowly it goes down and the casing pipe is going down slowly, and after reaching to the thing, then we introduce the strainer pipe and the blind pipe into it, and now basically the entire well is being shrouded by gravel. Then percussion drilling method, this is a cable tool method. This is a standard method which is being used by anyone actually outside. Naturally through this you can go up to 750 feet, you can go it. This is the boring rigs which we have generally seen in any of the places, rigs, and all the entire equipment is kept on the what you call it as on the vehicle, and only thing is the bore is being rigged and the casing pipe at the end they will remove it. So this is also one of the other methods, but you can go up to 250 meter into this. The rotary drilling method. A rotary drilling method is also same as the second method which I mentioned. Again here also we are sending basically what we call it as water into it, into the thing, thereby making the entire thing to be what you call it as a slurry, and that slurry is being removed outside. This is another method actually, but each depending upon the soil we can go it, and here this can go up to 300 meters. So this is another method, jetting method. So finally, if you look into it, one is the driving method. So that is what boat driving. So it is up to 20 meters, especially for loose sand, you can use this method. And boring actually up to 50 meters soil and medium soils. Then percussion up to 250 meters. That is what the third boring actually. Then wash boring is up to 50 meters and jetting is also up to 25 meters, whereas rotary is up to 300 meters you can go. So any one of the method depending upon the depth you need to operate to construct the well, you need to choose the thing. Depending upon the soil, the type of the well you are choosing differs. Then what do you mean by well shrouding? Excellent bit actually. What do you understand by well shrouding? Shrouding means placing a gravel pack around the well screen or strainer to prevent fine sand from entering the well. So well shrouding means placing gravel around the well screen as a filter is what we call it as the well shrouding. Plus, arranging the gravel pack around the strainer so that the fine particles will not enter into the pipe. So that is the purpose. So that is what we call. It acts as a filter. First thing, it increases the effective area of water entry, thereby it improves the discharge. It protects the strainer pipe from clogging or erosion. Right? How it is done? When the borewell is drilled, the annular space between the borehole wall and the strainer pipe is filled with properly graded gravel, and this is what we call it as shrouding material. The gravel should be coarser than surrounding aquifer material but smaller than the slots of the borehole. It improves efficiency, it improves yield, and it reduces the entrance velocity, lowers the chances of sand pumping, increases the well life. What do you mean by second definition? One is well shrouding, second one is well development. So well development is nothing but cleaning and stabilizing the zone around the screen to improve permeability and ensure sand-free water. So what we will do? The well development is a process of removing the fine particles such as sand or clay particles or silt from the area surrounding the strainer. From the area surrounding the strainer, you need to remove the fine particles once the well is constructed, so that only the coarse particles are there surrounding the strainer, and this method is called the well development. Why? To create a highly permeable, because the moment actually the fine sand clay particles are there, it obstructs the flow of water into the well, right? So that is why the well should be surrounded by always coarser particles. So for example, if any of the fine particles are there, that has to be dislodged, that has to be removed. That is why I told cleaning and stabilizing of a zone surrounding the strainer to improve the permeability of the soil to ensure the sand-free water. That is the fundamental thing. To ensure sand-free water supply, to stabilize the gravel pack and aquifer material. Anyhow, well shrouding means to fill the gravel pack. But the gravel pack, once picked after some time, naturally it is filled with the sand particles. Cleaning all that actually and making that zone such that free of sand particles is what we call it as well development. Right? So methods of well development is over pumping method. So the pumping water at a high discharge rate to remove the fine material. That means we pump water into the well. We pump water into the well. So therefore, that means fast we will do it. Then backwashing. Backwashing means forcing water. The over pumping method means pumping water at a very high rate. So naturally, the entire gravel pack gets disturbed and all the loose particles will be removed from there. That is one. Whereas second method, backwashing method, means forcing water back into the aquifer and then pumping out. So the moment you force the water into it, all the sand particles will go larger distance, so that that cleaning is happening. That is next thing. Then surging method, using a surge block or a plunger to alternatively force water in and out through the screen. So water in and out, just if you do like that, they get agitated. Or you send compressed air and thereby remove all the fine particles. So these are some of the things which are used for well development actually. By doing that, what is the impact is the increase the discharging capacity, ensures clear sand-free water, prolongs life of the well. The last topic of this particular groundwater hydrology is what are characteristic well losses. The well losses can be classified under two headings. One is aquifer losses and the other one is the well losses. The aquifer losses are losses due to water moving through the soil or rock towards the well. Whereas well losses means the extra loss due to flow through the well screen, pipe and turbulence near the well. So these are the two losses which we call it as the characteristic losses of the well. And to express these losses, we use well constants. In order to express the what you call it as the characteristic well losses, we use the well constants. So if I express it, how the total drawdown in a pumping well, if you take it, it can be represented by BQ plus CQ square. So the drawdown versus discharge relation is such that it is S is equal to BQ plus CQ square, where Q is the discharge, S is the drawdown, and B is the aquifer loss constant, whereas C is well loss constant, right? These are the two things. So what is this B? B is the aquifer constant. So that aquifer constant depends on the permeability and thickness of the aquifer actually. So the loss is directly proportional to the what you call it as the discharge BQ, kindly remember. Whereas this is B is aquifer dependent, whereas C is well dependent. So it depends on the well construction, and it depends upon the screen conditions and the efficiency. So because of this, some extra head loss is there, and it is non-linear, and it is represented by CQ square. Finally, what is B and what is C? B tells us about the aquifer. C tells us about the well construction or well condition. This is the thing. So final thing is drawdown is equal to BQ plus CQ square, and for final takeaway is total drawdown is equal to aquifer losses for well losses, and B represents the aquifer properties and C represents the well construction quality or the condition. A good well means a small value of C, that means less turbulence and efficient. Then a poor well means large value of C. Large value of C indicates it is entry of sand, clogging of the well actually, and higher losses. So with this actually the groundwater hydrology has been completed. Kindly follow each lecture in this groundwater hydrology, and let us take with the next part of this unit in the next class. Thank you so much, and I once again acknowledge both the authors of the textbooks, both P.N. Modi and B.C. Punmiya, from where we have taken most of our things, whatever explained in these lectures. So we acknowledge the help by these two textbooks which have rendered to us. One is Irrigation, Water Resources and Water Power Engineering by Modi, and the second one is Irrigation Engineering and Water Power Engineering by B.C. Punmiya. With this, thank you all, and we meet in the next lecture. Thank you. All the best.
Like, share and subscribe. Hit the bell icon for more updates.